Alright then, nearly done. Number 11. A class consists of students studying Spanish or French or both. So as soon as we've been given that there are some people or some objects belonging to multiple groups, we're immediately thinking, I hope, Venn diagram, as opposed to when you've been given a choice between this event occurring or that event occurring. And that implies some sort of tree diagram. So you just get a feel for which strategy, which visual diagram is going to help you solve the problem. And so in this case we've got Spanish or French or both. You see that it doesn't allow the possibility that somebody studies neither. And so I think that when I draw my Venn diagram, Spanish, French, I'm going to have 0 on the outside, because the class consists of students studying Spanish or French or both, not neither. 15 students study Spanish and 12 study French. The probability, so there's, okay, so this entire circle is going to be 15, and this entire circle is going to be 12. But I don't actually know how many are in these 3 regions yet. I suppose I could call them A, B, and C, and I could note for now that A plus B is equal to the total of Spanish studiers, which is 15, and B plus C is equal to all of the French studiers, which is 12. Alright, let's go on. The probability that a student studies French, given that she studies Spanish, is 7 over 15. Alright, you have been given that she studies Spanish, and we know that the given probability is always the one on the bottom. We've reduced our field of vision to only these 15 Spanish studiers. Now that's no surprise, because we can see that the total number of Spanish studiers, A plus B, is 15. The probability that a student studies French under these circumstances is 7 over 15. So of the 15 Spanish studiers, 7 of them are in the French circle. So this shows us then that our Venn diagram, the overlapping region is 7. And we had a total of 15 in the Spanish, that must leave 8 on the outside. And we have a total of 12 in the French region, and that must leave 5 in that part. And now we've got our complete Venn diagram, adding up to a total of 20 students in the class. So we've done part A, we've drawn a Venn diagram. There's 0 on the outside, of course. Find the probability that a student studies Spanish, given that she studies one language only. Alright, so I've given you that she studies one language only. And so let's look at, that's the new denominator, isn't it? Because we're only considering those people. So the new denominator is 8 plus 5, 13. There's only 13 people who study one language only. So knowing that we are looking at one of those 13 individuals, because that was given to you, what is the probability that the student studies Spanish? And of those 13 individuals, it's 8 of them who study Spanish. Number 12. "100 families with some dogs, cats, and birds." We need to draw a Venn diagram, so let's, these can be the dogs, these can be the cats, these can be the birds. Oh shoot, they've given us different letters, haven't they? So, let's backtrack a bit. Try that again. These could be the dogs, which is set S. These are the cats, which is set Q. And these are the birds, which are set R. Now we need to fill in the information. The best information to fill in first is either the very outside or the very inside. The very inside is given down here where it says 4 owned all 3 types of pets. Let's fill that in straight away. Alright, now let's kind of, because we started at the middle, let's work our way from inside out. So we've got 4 in the middle. What else? 3 owned dogs and birds, but not cats. So they owned dogs and birds. They're in the S and the R region, but they are not in the Q region. So there are 3 in the S and R region, but not in the Q region. 8 owned birds and cats, so 8 are in Q and R, but are not dogs, so are not in the S region. So that's 8 here. And 16 owned dogs and cats, that's S and Q, but not birds, so that's 16 right here. Now so far, if I look at my dog circle, I've got 16 plus 4 plus 3. That's a total of 23. But there's 56 who own dogs. 56 minus 23 is 33 in this region. Now then, let's look at the cat circle, Q. 38, 16 plus 4 plus 8 is 28. 38 minus 28 leaves 10. And lastly, 22 owned birds. I've got 15 so far. Here's the other 7. Now if I add all of these up together, 33 plus 16 is 49, plus 10 is 59, plus 3 is 62, plus 4 is 66, plus 8 is 74, plus 7 is 81. But I surveyed 100 families. That leaves 19 others on the outside. And that's the answer to part B, so I've now done parts A and B. Part C, find the percentage of families that own exactly one pet. So exactly one pet, 33 plus 10 plus 7 gives me 50, and the 50 is over the 100 families, and that is of course 50% of the families. And lastly, part D, a family is chosen at random. Find the probability that they own a cat given that they own a bird. I have given you that they are one of these 22 individuals. So we're only looking at the bird circle. So there's only 22 people that we're considering, families that we're considering, because we know that they own a bird. How many of those 22 families in the R circle are also owning a cat, are also in the Q circle? And we see that there's 4 plus 8, a total of 12 out of 22, and that reduces to 6/11ths. Yes, you can express it as a decimal or a percent. Just make sure you round to 3 significant figures. Number 13. Survey of 400 people. There's the table summarizing the results. One person is chosen at random from those surveyed. So we're looking at the 400 people that were surveyed. Find the probability that this person does not prefer Zoochos. Alright. Does not prefer Zoochos. Well, that means that they are not in the Zoochos, because these are the ones who do prefer Zoochos. And so if they don't, then it must be these 100 and these 180, a total of 280 individuals. Another way you could do this, of course, is taking the 400 total people and subtracting the ones who do prefer Zoochos. 400 minus 120 will also give you 280. And this, if you're interested, reduces to 7/10, 70%. Prefers Chocos given that they live in Montevideo. So I've given you that they live in Montevideo. I've given you that they are in this 210 people who are living in Montevideo. So the new denominator is 210. What is the probability that they prefer Chocos, given that they live in Montevideo? So not only do they live in Montevideo, but they prefer Chocos. They must be these 57. So it's 57 out of 210, and that does reduce actually to 19/70. I'm not sure what that is as a decimal or a percent, but just make sure you round to 3 or more significant figures. Part B, 2 people are chosen at random. Alright, now that's a clue to you that we're selecting first one and then selecting a second one. So we're making 2 selections here. We are choosing, which means that we're either going to have success or failure on any particular event. Find the probability that they both prefer fruity. So we can have prefer fruity or they don't prefer fruity. And then they can prefer fruity or not. They can prefer fruity or not. Alright, here we go. So what is the probability that the first person that you select prefers fruity? Well, there are 180 people out of 400 who prefer fruity. So it's 180 over 400. Now, how many people are left for you to choose from? You've already selected the first person, so there's only going to be 399 people left. So we made one selection with this probability, and we are now making a second selection. We did not replace the first person. That's why the denominator has changed. You always have to look at a problem, though, to see, because sometimes we do replace the original the original object that was selected, in which case the denominator would remain unchanged. It would be an independent event. This is dependent because the person that we selected, it will change the second probability based on whether the first person did prefer fruity or not. Because I've already selected a fruity preferer, that leaves only 179 of them left. So, in order to get that probability, 180 divided by 400 times 179 divided by 399 gives you 0.202 if I round to 3 significant figures. And the last problem on this review is number 14. Sharon and Lisa share a flat. Sharon cooks dinner 3 nights out of 10. So Sharon cooks dinner 3 nights out of 10. That's 0.3. Lisa must do it the other 7 nights out of 10. Now, if Sharon does not cook dinner, then Lisa does. Okay, well, here we go. That's why it adds up to 1. It's 100% probability that one of them will cook dinner. If Sharon cooks dinner, here we are, Sharon cooks dinner, so if this has occurred, then the probability that they have pasta is 0.75. You can see that filled into the diagram already. Well, that must mean the probability that they don't have pasta is 0.25. So I guess Sharon, not only does Sharon not cook very often, she also always makes pasta. Now, if Lisa cooks dinner, which happens more frequently, then the probability that they have pasta is only 12%. And that must leave 88%, 0.88, that they don't have pasta when Lisa cooks. So she provides, I assume, a much greater variety of food. Part B. Find the probability that Lisa cooks dinner, and they do not have pasta. So that's going to be this outcome right here. So that is found by taking 0.7 times 0.88, which gives us 0.616. There's the answer to part B. Part C, find the probability that they do not have pasta. Well, we've already figured out part of this probability that they did not have pasta. There was 0.616 chance of them not having pasta when Lisa's cooked, but there's another way that we could not have pasta when Sharon cooks. 0.3 times 0.25. which gives you 0.075. So, the total probability that they do not have pasta is going to be the sum of these two amounts, which gives you 0.691. And the last question. Given that they do not have pasta, so I'm giving you that they do not have pasta. Let's write that probability down there on the bottom. They do not have pasta, right? We just worked that out in part C. I'm giving you that we're now only looking at that part. Find the probability that Lisa cooked dinner. So I'm just going to remind you. So given that they did not have pasta, this is what's being given to you. So we back up. What was the probability that Lisa cooked dinner given that they did not have pasta? Alright, so according to the probability formula, that's going to be equal to the probability that Lisa cooked and they did not have pasta divided by the probability that they did not have pasta. Always the probability of both divided by the probability of the given event. So now the probability that Lisa cooked and they did not have pasta, we've already found this in part B. It was 0.616. So there's my numerator, and you can see I've already filled in my denominator, the probability of not having pasta, which we found in part C. So let's just take the ratio between these two amounts, 0.616 divided by 0.691, and we end up with a final answer of 0.891 when I round to at least 3 significant figures. So 0.891 is my final answer. Good luck with your studying. See you for the test.